Wind energy is really indispensable if we look at sustainable energy systems. We need wind, we need significant input of wind if we really want to move towards sustainable energy systems. On land, wind is already competitive with conventional fossil fuel power plants, so that is something which is technologically also quite well developed. But on land there's limited space to build all these wind turbines, and there is also a lot of public resistance against building wind turbines. So there is a strong movement to go offshore. And offshore really means far offshore, more than 50, 60, 70 or even perhaps 100 kilometers offshore, so you will not see these windmills even. And there is a much more constant flow of wind, which is also a big advantage for this means of sustainable power production. So there is quite some movement at this moment to develop offshore wind energy, but it's much more expensive. It's not really competitive to fossil fuel power plants at this moment, so it needs to be subsidized or stimulated in one way or another. So there is an issue, do we want this or not? There is also an issue, who has to develop this network there offshore, and offshore is also not empty water. There are a lot of rights for fishery, for recreation, for military or naval transport. So this is far from a free North Sea. There are all trajectories for these different users, and wind has to be placed within that. And that's not a trivial issue. So we also have to consider all these different interests and other groups that do want to use the North Sea, and then we want to place wind power there in between somewhere. The environment is very harsh, of course. You can imagine all these storms and salty water, so you cannot just take onshore wind turbines and put them offshore. That will not work. So you need really different constructions. You need to drill it in the ground. The North Sea is not so deep, but still it's quite expensive to make these foundations. And you also need to develop the network there offshore. Onshore we have a network, and you can quite easily connect to the network without huge expenses. But imagine you build a wind park 100 kilometers out of shore. So you need to develop all these cable connections over there. And if you imagine there is now the discussion to have a plug outside on the water, so all these wind parks can connect to the plug. One plug, such a platform, is huge, and it costs about €1 billion. So this is really big money. One of the big discussions we have at this moment is in the Netherlands whether TenneT, the system operator for onshore cables, should also be the system operator for offshore. And there's a huge discussion on that. And that's closely related to the issue, should we socialize the cost for building all these cable connections offshore or not? Or should that be covered by the operators who build the wind parks there offshore? And yeah, there are pros and cons for both. But if you consider that offshore wind is a long-term option for several decades, then it might make sense to have the national system operator being there and providing these cables and networks. But another issue is then, if you develop this network, you also would like to connect it internationally. It's not only a Dutch issue, it's Germany, it's Denmark, UK, and so forth and so forth. But then you get very interesting questions, because Germany has another energy policy as the Netherlands. And it might be very tempting or attractive to export wind power from the Netherlands to Germany, because the subsidies are bigger in Germany. So you would draw subsidies from Germany to the Netherlands, and the Germans would not be very happy on that. And yeah, we have a lot of these kind of disputes. And another additional issue with offshore wind is also that if we build these far and large offshore wind turbines outside the 12-mile zone, it's not anymore the law as we know it in the Netherlands. It's international law. Yeah. So how you regulate in these international waters the production of energy between countries. So it's extremely challenging. Yeah, load balancing is a very important issue if you look to sustainable energy production, because the availability of wind is not always in line with the need for power, and the availability of sun for solar PV is not always in line with the need for electric power. So there's a huge discussion going on the storage of electricity and perhaps even other means of energy. So this power to gas discussion, could we use a surplus of wind power energy in the North Sea to change electric energy into hydrogen? So you would need water, and then you could produce hydrogen, and you could store hydrogen, and you could use it then in times that you would have a need of power. That of course costs a lot of money, and there is a discussion going on whether it's worthwhile to do that or not, because you also lose energy. And on the other hand, you might also consider not only to take to use the power as demand asks for it, you might also try to influence the demand for electric power. So under which circumstances would industry be willing to shut down some production plants if there is a shortage of energy? How and to what degree would households be willing to reduce their energy use if there is a shortage of provision of energy? And these are all very interesting challenges, and you can do a lot with regulation, giving price signals, for instance, introducing these smart meterings. So there are technical solutions for that, storage, but there are also institutional regulatory solutions for that, and the trick will be to find the right combination between both of them. At the moment I'm doing research on social responsible innovation. So it's not only an issue on whether you get the right technology or the right regulation, but it's also an issue of what kind of moral values does society associate with certain technologies. So what kind of moral values are embedded in wind systems, or what moral values are incorporated in certain kinds of regulations. So for instance, if you think that TenneT, the system operator, should build the offshore network there, by this kind of regulation we would admit that this is a social responsibility to build offshore wind there, which is also related to the issue that society thinks that offshore wind is important. So it's an ethical statement. And if you build wind turbines far offshore, so you will not see them, then this visibility is also some kind of ethical value, which is then dealt by a more complex and costly solution to build these wind turbines far offshore, because you will not see them. So inside the technological choices and the regulatory choices, there are certain values, ethical values, social values embedded. And if we develop these offshore wind turbines or wind parks, and if we develop solar power PV systems or other energy systems, we need to be very much aware of these kind of values which are sometimes embedded in technical or institutional choices. And I think this social acceptability and social acceptance of future energy systems is very decisive for the success of it.